We're going to plot points, find the distance between those points, and also we're going to add in finding the midpoint of the line segment that joins those points. Our first set of coordinates, we have 2, -6, and 2, 2. On the grid to your bottom right, starting at the origin, you go to the point 2, 2, and then go back to the origin, and we also plot 2, -6. Now, because the x coordinates are identical, the line segment connecting these 2 points forms a vertical line segment. So the distance is not hard to count at all because you just count 1, 2, 3, 4, 5, 6, 7, 8 units. It's whenever the line segment has a slant or a diagonal orientation that distance will fall back and use the formula. Midpoint, you can also count that because there's 8 units total from point to point. We know that 4 points away from each endpoint is where the midpoint will be. Now, as far as calculating midpoint, you add up your x's, divide by 2. All you're doing is find an average. And then you add up your y coordinates, divide by 2. And so 4 over 2 gives us 2. -4 divided by 2 is -2. So sure enough, if you go to the point 2, -2, that is exactly halfway between the 2 points from the problem. In our second example, we have a brand new set of ordered pairs. We have 3, 9, and 8, 0. 3, 9 is this black dot. 8, 0 is this black dot. The line segment connecting those two, we're going to look for the distance and the midpoint of that line segment. So for distance, recall, here's your formula for distance. It's really just a derivative from your Pythagorean theorem. We're also going to check that technique out. But first things first, x2 minus x1, that's 8 minus 3, quantity squared. So that gives us 5 squared. And then we add the difference in the y's, 0 minus 9, that's -9 quantity squared. 25 plus 81 is 106. The square root of 106 is the exact distance between the points. If we approximate, it's 10.3 units. So this black line segment is 10.3 units in length. If you wanted to work this one using Pythagorean theorem, it is totally appropriate. What you would do is you would create a right triangle where the line segment joining the points in your problem forms the hypotenuse. So we take one point, this one up here at 3, 9, and we drop a vertical line straight down. That has a length of 9, and then we go straight across to the other point, and that has a distance of 5, so that leg of the triangle has a length of 5. Remember that Pythagorean theorem, hypotenuse squared, so that's d squared, is equal to leg squared plus other leg squared, 9 squared plus 5 squared. Well, 81 and 25, that adds up to 106, and that's equal to the length of the hypotenuse squared. So if we take the square root, that still gives us square root of 106. If you prefer to do these with grids or graph paper and a straight edge, by all means do it that way. The midpoint, the point halfway along this hypotenuse, or the line segment joining those 2 points from the original problem, we add the x's, so 3 plus 8 over 11, that's 11 over 2. Then we add and average the y's, 9 plus 0 divided by 2, that's 9 halves. So this is your midpoint, 11 halves and 9 halves. It's probably easier to visualize where those are if you convert them to decimals. 11 divided by 2, that's 5.5. 9 divided by 2 is 4.5. So if you go from the origin, you go right 5.5 and then up 4.5, sure enough, that's the midpoint of that line segment. The final example we did was a soccer player passes the ball from a point that's 18 yards from the end line and 12 yards from the sideline. A teammate who is 42 yards from the same end line and 50 yards from the same sideline receives the pass. Thank goodness for the diagram because I'm not real familiar with soccer. I mean, I've watched it, but I've never played it like formally. Anyway, long story short, we're asked to find how long the pass is in yards. So luckily the points are given for us, and we just need to find the length of that pass from here to here. Okay, so that's distance formula. Now in class we also did Pythagorean theorem. We constructed a horizontal leg and then a vertical leg. Turns out that leg is 38 units long and this leg is 24 units long. Using the distance formula, x2 minus x1, that's 50 minus 12 squared, that's 38 squared. Y2 minus y1, that's 42 minus 18 quantity squared. 42 minus 18 is 24 squared. We broke out the calculators. 38 squared plus 24 squared is 2020. Square root of 2020 is the exact distance of the pass in yards. We approximated to the nearest whole number, and we got 45 yards. Be careful, WebAssign. I try to copy paste as much as I can from there so that the examples I present in class will match what you'll be expected to do on there.